Yo, 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 yo. So back at it again. You know what I'm saying? So we're looking at question number 26 now. Okay, question number 26. It says the table shows the volume of water Y in gallons recommended for X fish in an aquarium. What is the average rate of change from 2 fish to 10 fish, and what does it mean? All right, cool. So this looks like that one particular equation that we talked about from before at the beginning of the lesson. Uh-oh, my thing ain't even connected. My bad. All right. All right, there we go. So we should be good now, right? Let me see. Maybe not. All right, cool. Let's just go back to the one particular equation we talked about at the beginning of the lesson. This one right here. You need to know about the rate of change. Y2 minus y1 over x2 minus x1. That's what we're going to do. Okay, so let's go ahead and get back to the actual problem itself because that's what they're asking for. Right here. There we go. All right. So we're looking at the rate of change. Okay. And that's going to be, they ask this question, what is the average rate of change from 2 fish to 10 fish, and what does it mean? So when we look at the average rate of change, we're going to be looking at 2 fish and 10 fish. Okay, cool. So the 2 is going to represent x1. Okay. So this is x1. So that means that this over here has to be y1. Okay. And then the 10 is going to be x2. So this has to be y2. Okay. So what we're going to do is we're going to go ahead on and type it in like 15 minus 5 over 10 minus 2. Now, you can use your scientific calculator to go ahead on and calculate this particular question. I'm going to actually show you guys how to do that, okay? So let me come over here. I'm going to go ahead and bring up the scientific calculator right here. And this is where I'm going to actually go ahead and do the actual operation, okay? So again, I think that was, what, 15 minus 5? Okay, so we're going to do 15 minus 5 at the top over 10 minus 2. And as you can see, we get an answer of 1.25, okay? So we already know that our answer right here is going to be 1.25, okay? And now we're going to interpret what that means, okay? So the average rate of change is 2. No, it's not. It was 1.25. Average rate of change is 2. No, it's 1.25, okay? The average rate of change is 1.25, right? Meaning that for each fish added to the tank, 1.25 more gallons of water are recommended. And this one says the average rate of change is 1.25, meaning that for every 5 fish added to the tank, 4 more gallons. Nope, that was not it. This is going to be the correct one. And we can move on from there. Okay, cool. So that's what that means. The average rate of change is 1.25, meaning that for every fish that was added, we need to add 1.25 more gallons of water. Okay. All right. The next question is going to be question number 30. Okay. Question number 30. All right. So question number 30 says, what is the degree of the quotient? Now, I don't know if you may have a question that say, hey, what is the degree? But in order to find it out, we will do this division right here. So you will see some questions that will ask you to divide. Okay. So here we go. So I'm gonna do this on a separate sheet of paper. This has 2x to the 7th plus 2x to the 5th, right? And plus 24x to the 3rd. And all of this was being divided by a 2x to the 2nd power. Okay, cool. So here we go. Now, what you can do is you can split everything up. So you can have a 2x to the 7th divided by 2x squared, okay, plus a 2x to the 5th divided by 2x squared, and then plus a 24x to the 3rd divided by a 2x squared, okay? Now, we already know that when 2 divided by 2, that's going to cancel out. That'll just be 1. Now, x to the 7th divided by x squared, remember, that just means you have 7 x's multiplied to each other, right? I'm just going to do this one particular one right here. So 1, 2, 3, 4, 5, 6, and then 7. 6, 7. Divided by x squared means x times x. So how many x's can be canceled out? So this x can cancel out with this x, and this x can cancel out with this x. So I have 5 remaining left over. So I should have an x to the 5th with this one, okay? So again, 2x to the 7th divided by 2x squared is just an x to the 5th, okay? Plus here, the 2's will cancel out again. I have 5 x's at the top, 2 x's at the bottom. Therefore, I should have how many left over? Correct, 3. This should be an x to the 3rd, okay? And then here I have 24 divided by 2. I can do that. That can simplify down to 12. And then if I have 3 at the top, 2 at the bottom, how many will be left over? 1. There we go. So this would be my answer right here. Okay. Now, if they just asked me to do this on the EOC, this would be the final answer. But remember, the question said, "What is the degree of the quotient?" Okay. So the quotient means the to divide. So the degree means which term has the highest exponent, and the highest exponent here is 5. Okay. So I'm gonna have a degree of 5. That's that answer. Okay. Alrighty, the next question that I'm going to do is going to be question number 32. Okay, 32. Let's look at that one. Oh, let me go back. Alrighty, so question number 32. It says the following graph represents the decay of a radioactive substance. Which exponential function is represented by the graph? Now the graph is not showing here. I don't know why it's not showing there. That's crazy. But okay, I'll go ahead and do it anyway. Okay. So we just want to know which one represents an exponential decay. Now remember, an exponential function is a times b to the x. And decay means that the b needs to be between 0 and 1. So it needs to be like a decimal that's less than 1 but greater than 0. Okay. So here, this is not it because, well, that could be it. Let's see. An exponential decay, radioactive decay. Okay, cool. Yeah, this is not showing the graph here. My graph, and I think in your book, the graph is starting kind of close to 1,000. So that's going to be our initial value. That's going to be our A. So it looks like this is going to be the correct answer here, okay? And it's going to decay. And we know it's going to be this one because it's 0.75 as the B. Okay, cool. So that should be it. So just in case you don't see it here, if you look in the book, you should see the graph, okay? Again, I don't know why it's like that, but that it is what it is. Alrighty, this one says, which formula is equivalent to the simple interest formula A equals P times R plus, 1 plus R, okay? So all of these are written in forms of R. Now, you might not get a multiple choice question like this on the test, but it will say, hey, solve this particular equation in terms of R, meaning that you need to get R by itself, okay? So if I want to get R completely by itself here, I'm going to go ahead and do this right here. I'm going to have A equals P times 1 plus R, okay? So the first thing I need to do is I need to get rid of this P. This P has been multiplied to everything that's over here on the same side as R. So I'm going to divide both sides by P first, okay? So now I'm going to have A divided by P equals 1 plus R. And now I can drop the parentheses because there's nothing that's being multiplied to that grouping, okay? Now, the next thing I'm going to do is, remember, I need to get R by itself. So if I need to get R by itself, then I need to get rid of the 1. And the operation between R and 1 is addition. And that 1 is positive, so I'm going to subtract 1 on both sides. So minus 1 here, minus 1 here, okay? So in that particular case, All right, students. Okay, so sorry about that. Announcements came in. Anyway, so this 1 cancels out here, okay? So now I'm just going to have A divided by P minus 1 equals R. Now I have R completely by itself, okay? So in that particular case, the correct answer here would be A. All right, it's going to be A. Okay, the next question I'm going to have here is question number 34. Okay. Alrighty, so 34, it says, describe the transformation in g of x equals 2x plus 7 as it relates to the graph of f of x equals 2x. So basically, they started from f of x and then they're going to g of x. So they want to know what happened from f of x to g of x. Well, it's a linear function here. And so the only difference that you see is what? You see that it's going to be a plus 7. And so since the plus 7 just happens to transfer the f to the g, then it means you just went up 7 spaces. That's all. Okay, just went up 7 spaces. That's it. Alrighty. 38. Let me see. I don't know if I have enough time for 38 on this particular video, but I'm gonna try. 38. So let's just read this question for a moment right quick, because it's going to take you some time. Again, all of these questions will take you time to do it. You just can't fly by these just like that. You're going to have to know how to spend time with the question, okay? So here it says a recent survey indicated that 70.1% of households in Clarksville own at least one car. The survey had a margin of error of 1.2%. Margin of error. Of the households that own a car, the average number of vehicles in that household was 1.7 with a margin of error of 0.1. Okay, cool. So it looks like it's a double margin of error here. In the If the number of households in Clarksville is 120,313, what is the estimated lowest number of cars in the city? Okay, cool. Okay, all right. So here we go. We're going to be looking at a margin of error right here. And you will see some problems about margin of error. You are definitely going to see some problems with margin of error, okay? If you look at in the past, and I'm basing this off of past assessments, they've always asked about the margin of error, okay? So margin of error. All right, cool. So what is this problem talking about here? They're talking about people who live in a particular town called Clarksville. And they're talking about, hey, in Clarksville, 70.1% of the people that have a household there or that live there own at least one car with a margin of error of 1.2%. So that's the first thing we need to find out. We need to find, okay, cool, what is going to be our upper and our lower part, okay? So if I do that, I'm going to have, let me do 70.1% plus or minus 1.2%. And the reason I'm saying plus or minus 1.2 because that's our margin of error, meaning that at any given time that when they did the survey, from ever since then, it could go up by 1.2% or down by 1.2%. Okay. So let's do the lower part first. Let's go down by 1.2%. So if I do 70, and you can use a calculator if you wanted to, but I'm just going to use this right here. If I do 70 minus 70.1 minus 1.2%, let's see. This is going to be a 6 here. This is going to be a 9 here. This is going to be a 10 here. So this is going to be 8. This is going to be this is going to be 8. Excuse me. 9. This is going to be 8. This will be 6. So 6.88. Okay. Right. 1.2%. Right. Let me see. 70.1 minus 1.2. 68.9. Where am I? Why am I not getting that? Ah, my fault. Ooh, that's a big mess up on me. Big mess up, big mess up. 70.1 minus 1.2. This should be 6. This should be 9. This should be 11. My fault. 11 minus 2 is going to be 9. 9 minus 1 is going to be 8. And this is going to be a 6. So 68.9 should be the lower part or the lower percentage. And then if I do the higher part, I'm just doing 70.1 plus 1.2%. So this should be 71.3%. Okay, cool. That's the upper part or the upper percentage. Okay. Now, what I'm going to do is I need to find out the lower percentage of this population and the upper percentage of this population. Okay. So what I'm going to do is I'm going to use my scientific calculator. So I'm going to go back there and I'm going to show you guys how to find the upper and the lower part of that. Okay. Okay. All right. So the lower part is going to be 0.0 689 times the population. And that population was 120,313. Okay. So that's the lower portion, which is 82,895 people. And we can say 0.657. Okay. And then if we wanted to find the upper part of it, okay, we would change that to the 71.3%. Ooh, 71.3, which is 0.73. And the reason why we change it is because we want to go from a percentage to a decimal. Okay. So the upper part would be 85,783. Okay. Now, if you was doing this on a particular question, they might just ask this. You rarely you need to do a double margin of error. Okay. But if you was doing this on an actual question, they might just say, hey, what's the lower part of people who own at least one car? What's the upper part of amount of people that at least own one car? So if they were just asking about the amount of people who at least own one car, you would just go, cool. The lowest amount would be 82,896 people. And then you would type in the upper percentage, and you would say the most would be 85,783 people. That's it. Okay. But this question asks us a different question. It says, remember, it says the average number of vehicles in the household was 1.7 with a margin of error of 0.1. Okay. So that means that if I go back down here, right, this can go down to as well. Or basically, what I now need to find is that I need to find out how many, what does it say? What is the estimated lowest number of cars in the city? Okay, cool. So I know the lowest percentage, which is right here, 82,895 people. But remember, it's a 1.7 cars in the city that can go up by zero point 0.1 or down by zero point 0.1. So if I'm gonna go down by 0.1 from 1.7, that's gonna be 1.6. Okay. So I'm gonna type in 1.6 here. So the lowest amount of cars in the city would be 132,633. Okay. Again, 132,633. All right. So let's see if that's going to be one of our answer choices. Okay. All right. So again, just to go back here, and I don't want to confuse anybody just in case I did. Remember, the question here says, what is the estimated lowest number of cars in the city? Okay, cool. So I need to just look at the lower end of everything. Now remember, in the city itself, it says every household owns at least 1.7 cars with a margin of error of 0.1. So if I'm at 1.7 plus or minus 0.1, then the lowest part is 1.7 minus 0.1, which is 1.6. So that's the reason why I multiplied the 1.6 times the lowest part. Okay. And when I did, I got 133,000. Yep, this would be 132,000. This would be the correct one right here. Here we go. Oh, come on now, get it right. Get it right. There we go. That's the best I can do. Okay. And I think that is it for the intermediate ones. Yes, that is it. Um, Again, remember to always write down those particular forms that we talked about at the beginning of the session. Okay, that's one thing. The next thing as well is to just make sure you read the problems and read them more than once. Okay, you got to read them at least, at least 3 times. All righty. If you have any questions at all, you can try to email me. But by the time you see this, it'll probably be time you take the test next day. Okay, so good luck to you all.